What do we have here? Rum and raspberry flavor. Oh hey, welcome to Insane Curiosity. Did you know that the clouds at the center of the Milky Way smell of rum? What you're about to see is not a video. It's a bunch of weird facts. Of them we gathered and brought to you many, the best ones. Oh, I almost forgot. Your zodiac sign? It's probably wrong. I'm sorry. Follow me on this video about astronomy facts. You can watch with your turtle. It will be amazed to know that some of its friends flew around the moon. Did you know that the clouds at the center of the Milky Way smell of rum and raspberries? Finding amino acids in interstellar space is a holy grail for astrobiologists, as this would raise the possibility of life emerging on other planets after being seeded with the molecules. In the latest surveys, astronomers sifted through thousands of signals from Sagittarius B2, a vast dust cloud at the center of our galaxy. While they failed to find evidence for amino acids, they did find a substance called ethyl formate, the chemical responsible for the flavor of raspberries. Curiously, ethyl formate has another distinguishing characteristic. It also smells of rum. Did you know that 1 teaspoonful of Neutron Star would weigh way more than the entire human population? A neutron star's density is mind-boggling. These stars are composed almost entirely of neutrons packed together in a tiny radius. Just a teaspoonful of this material would weigh over 1 trillion kilograms, more than the weight of the entire human population, which reaches a few 100 billion kilograms. To make something as dense as a neutron star, the whole of humanity would need to be crammed into space the size of a sugar cube. On average, gravity on a neutron star is 2 billion times stronger than gravity on Earth. In fact, it's strong enough to significantly blend radiation from the star in a process known as gravitational lensing, allowing astronomers to see some of the backsides of the star. The power from the supernova that birthed it gives the star an extremely quick rotation, causing it to spin several times in a second. Neutron stars can spin as fast as 43,000 times per minute, gradually slowing over time, falling in the so-called pulsar graveyard, where they are no longer detected. Did you know that Neptune has only completed 1 orbit around the Sun since its discovery? Neptune's average orbital distance from the Sun is enormous. In fact, this distance is about 30 times greater than the corresponding value for Earth. Neptune is the 8th and farthest planet from the Sun. Neptune was first discovered in 1846. Since its discovery, the blue gas giant has only completed 1 orbit around the Sun. Did you know that sooner or later we will say goodbye to Polaris? Polaris, our North Star, isn't leaving us anytime soon, at least not for another 12,000 years. But when it does, the star Vega will replace it. Why? It's all about the rotation of the Earth. As our planet's axis changes over a very long 26,000-year cycle, the North eventually shifts to different stars. It won't be the first time Vega gets the starring role in our night sky. It was the North Star several thousand years ago. Actually, for the same reasons, your zodiac sign is probably wrong. Do you want to know why? Roughly speaking, the Sun appears against a different constellation every new moon, the stars forming a distant backdrop to the Sun. Though the stars are not visible during the daytime, you can know what constellation the Sun is in by looking at the nighttime sky. There you will see the opposite constellation. The main reason astrological signs fail to line up with the zodiac, though, is a wobble in the Earth's rotational axis called precession. As a result of its rotation, the Earth bulges slightly at the equator, not unlike how a skater's skirt fans out as she spins. The gravity of the Moon and Sun pulls on the bulge, which causes the Earth to wobble like a top. The wobble causes the Earth's axis, which is the center line around which it rotates, to swing in a slow circle over the course of 25,800 years. This movement alters the view of the zodiac from Earth, making the constellations appear to slide to the east, roughly a degree per human lifetime. Though slow, precession was discovered with the naked eye by Hipparchus of Nicaea around 150 BC. In ancient times, the vernal equinox, or the first day of spring, was in Aries. Due to precession, it moved into Pisces around 100 BC, where it is now and will remain until AD 2700, when it will move into Aquarius, and so on. Over the course of 25,800 years, it will eventually return to Aries and the cycle will begin again. Do you want to know what constellation was the sun in on your birthday? You can start counting from this. Aries, April 19th to May 14th. Taurus, May 15th to June 20th. Gemini, June 21st to July 20th. And so on. As you can see, your zodiac sign is probably wrong. Did you know that we've had turtles orbiting the moon? The Zond 7 was a Soviet probe of the Zond program. The mission involved studying the moon and space around it, obtaining color photographs of the Earth and the moon from various distances, and testing the probe systems. A biological payload of turtles, wine flies, mealworms, plants, seeds, bacteria, and other living matter was included in the flight. Additionally, according to the Russian Academy of Sciences, in the pilot seat was a 175 centimeter tall, 70 kilogram mannequin containing radiation detectors. The spacecraft was planned as a precursor to crewed lunar spacecraft. It represented the first successful Soviet circumlunar Earth return mission. Did you know that the moon is getting farther away every year? The ongoing Lunar Laser Ranging Experiment, or Apollo Landing Mirror, measures the distance between surfaces of Earth and the moon using laser ranging. Lasers at observatories on Earth are aimed at retroreflectors planted on the moon during the Apollo program 11, 14, and 15, and the two Lunokhod missions. Laser light pulses are transmitted and reflected back to Earth, and the round-trip duration is measured. The lunar distance is calculated from this value. As detected, the moon is spiraling away from the Earth at an average rate of 3.8 centimeters or 1.5 inches per year. Did you know that as seen from Earth, stars twinkle, but solar system planets don't? Stars twinkle because they're so far away from Earth that even through large telescopes, they appear only as pinpoints, and it's easy for Earth's atmosphere to disturb the pinpoint light of a star. As a star's light pierces our atmosphere, every single stream of starlight is refracted, caused to change direction slightly by the various temperature and density layers in Earth's atmosphere. You might think of it as the light traveling a zigzag path to our eyes, instead of the straight path the light would travel if Earth didn't have an atmosphere. Planets shine more steadily because they're closer to Earth and so appear not as pinpoints, but as tiny disks in our sky. You can see planets as disks if you look through a telescope, while stars remain pinpoints. The light from these little disks is also refracted by Earth's atmosphere as it travels toward our eyes. But while the light from one edge of a planet's disk might be forced to zig one way, light from the opposite edge of the disk might be zagging in an opposite way. The zigs and zags of light from a planetary disk cancel each other out, and that's why planets appear to shine steadily. You might see planets twinkling if you spot them low in the sky. That's because in the direction of any horizon, you're looking through more atmosphere than when you look overhead. If you could see stars and planets from outer space, both would shine steadily. There'd be no atmosphere to disturb the steady streaming of their light. Can you figure out which objects are stars and which are planets just by looking for the twinklers versus the non-twinklers? Experienced observers often can, but at first, if you can recognize a planet in some other way, you might notice the steadiness of its light by contrasting it to a nearby star. Did you know that before NASA, there was NACA? The National Advisory Committee for Aeronautics, NACA, was formed on March 3, 1915, with a charter to supervise and direct the scientific study of the problems of flight, with a view to their practical solution. With luminaries like Orville Wright as members, the group was on the cutting edge of technology in the early decades of flight, before eventually being absorbed by NASA in 1958. Did you know that no one has gotten lucky in space? Wink wink in space? NASA says no humans have had sex in space. Human sexual activity in the weightlessness of outer space presents difficulties due to Newton's third law. According to the law, if the couple remains attached, their movements will counter each other. Consequently, their actions will not change their velocity unless they are affected by another unattached object. Some difficulty could occur due to drifting into other objects. If the couple has a combined velocity relative to other objects, collisions could occur. There have been suggestions that conception and pregnancy in off-Earth environments could be an issue. As of 2009, with NASA planning long-term missions for lunar settlements with goals to explore and colonize space, the topic has taken a respected place in life sciences. Scientist Stephen Hawking publicly concluded in 2006 that possibly human survival itself will depend on successfully contending with the extreme environments of space. Did you know that the Andromeda Galaxy is the only extra-galactic object you can see with your naked eyes from the Northern Hemisphere? If you can spot the Andromeda Galaxy with your naked eyes, you can see something 2.537 light-years away. If you want to try to spot it, you have to find Cassiopeia first. Cassiopeia appears low in the northeast sky at nightfall and early evening, then swings upward as evening deepens into the late night. In the wee hours after midnight, Cassiopeia is found high over Polaris, the North Star. Note that one half of the W is more deeply notched than the other half. This deeper V is your arrow in the sky, pointing to the Andromeda Galaxy. Did you know that driving a car to the nearest star at 70 kilometers an hour would take about 65.5 million years? Proxima Centauri, the closest star to our own, is still 40,208 trillion kilometers away, or about 268,770 AU. When we talk about the distances to the stars, we no longer use the AU or astronomical unit. Commonly, the light year is used. A light year is the distance light travels in 1 year. It is equal to 9.461 times 10 to the power of 12 kilometers. Alpha Centauri A and B are roughly 4.35 light-years away from us. Proxima Centauri is slightly closer at 4.25 light-years. A car going at 70 kilometers an hour travels in a year about 613,200 kilometers. So if we wanted to use the car year, we would find it would take about 65,570,776.3 car years.